Hey everybody, this is section 6.3-3, extended multiplication rule, Bayes rule, which is just all of this, you guys, independence again and decision analysis. So all of this involves this Bayes rule thing. I'm not even sure if I pronounced that right. All right, let's begin. 5% in section A, 5% of high school male athletes go on to play at the college level. Of these, only 1.7% enter a major league pro sport. About 40% who compete in college and then reach the pros have a career of more than 3 years. Uh-oh, what'd I do? Let's see. What is the probability that a high school athlete competes in college and goes on to have a pro career more than 3 years? Okay. Well, that's just you just going through, you guys, and it's the extended multiplication rule. There, you just multiply each probability together, and you get 0.0003 So therefore, these three dots means therefore, you guys. At least they used to. I don't see them as much anymore. But therefore, only about 3 in every 10,000 high school athletes can expect to go to pro and play pro for more than 3 years. Okay, and those are just the athletes, you guys. All the other ones, that didn't play sports, they're not included in that. Okay, section B. There are few who go straight from high school to pro, like LeBron or Kobe. Suppose that these count for 0.0001, so construct a tree diagram. Okay, easy enough. So here's all male high school athletes, and I'm going to signify A as college sports and B as pro sports. So going on to college, you either went to college or you didn't. Okay, so all the male high school athletes, either you went to college or you didn't. So this is the complement of A. Okay, makes sense? Um, and then so put in the percentages, 5%, and that means 95% didn't. All right, and then so going on to pros, you guys, these guys went to pros, and then these guys are the complements, didn't go to pros. Okay, and then put their percentages in, and we get those right there. So 1.7, and then the complement of 1.7 is 98.3. Okay, and then down here is here's Kobe, and then here's me. Um, I played some baseball in high school, and I didn't go on to play baseball. I went on to college, but not to play baseball. Obviously, I went to college. And then so there's the 0.0001, and then there's the 0.9999 for me. Okay, and most of you. Okay, so note that the probability of reaching the end of any of these complete branches right here is just the product of multiplying. So if I wanted to find, this guy right here, I just multiplied this number times this number, and that'll get me the probability of going to extend out to each branch. Okay, so what's the probability of reaching B without college? Okay, well, that's pro sports without college. Okay, so let's go back to that diagram right here. Okay, without college, that's down here. So here's Kobe. He went from here to here, so it's going to be this number times this number right here. Okay, and you get 0.000095. Okay, about how many athletes will play pro sports? Okay, so again, when we go over here, who's going to play pro sports? You got these guys up here that play pro sports, and you got these guys right here that play pro sports. So this number times this number, and along with this number times this number. Okay, so there's going to be there's two ways to get to B. So the 0.5 times 0.017, and then finally the 0.95 times the 0.0001, and then you add those together. So of 9 in about 10,000 male high school athletes will play pro sports for more than 3 years. Okay, what proportion of pro athletes competed in college? Okay, so you got to find out, remember, probability is favorable divided by total. So what's the favorable that competed in college, and then the total that played pro all together. So probability of who was pro came from college, and then the total right here. Okay, so we found from before that this was 0.85, this was the 0.000945, 0.00085, sorry. And then so you get about 90% of the pros competed in college. Okay, when you crank that out. All right, and then this one gets kind of crazy. You'll see in just a second this tree diagram. Transplants or dialysis, okay? And this is example 6.25 on page 376 and 77. All right, so Lind has end-stage kidney disease. Her kidneys have failed, so she cannot survive unaided. Only about 52% of patients survive for 3 years with kidney dialysis. Fortunately, a kidney is available for transplant, so Lynn's doctor gives her the following information for patients in her condition. It gets kind of sad, you guys, sorry. Well, it's just kind of, it's real. So transplant operations usually succeed. After 1 month, 96% of the transplant kidneys are functioning. 3% fail to function, and the patient must return to dialysis. The remaining 1% of the patients, because 96 and 3% is only 99%, so the remaining 1% of the patients die within a month. Patients who return to dialysis have the same chance of 52% of surviving 3 years if they had not attempted a transplant. Of the successful transplants, however, these guys right here, of the successful, only 82% to continue to function for 3 years. Another 8% of those patients must return to dialysis, and 70% of those survive for 3 years of the people that return to dialysis, okay? And then the remaining 10%, because there's only 90% from 82% to 8%, and this 70% is the ones returning to dialysis. It's 70% of the 8%. Okay, and this remaining 10% is the 82% with the 8% right there. So the remaining 10%, sorry, of the patients die without returning to dialysis. Okay, so there's too much information here to sort through this without a tree diagram. So I'll show you this tree diagram, and I'm going to go back and forth in slides here. So the key is to realize that most of the percentages that Lynn's doctors gives her are conditional probabilities. So it's just a tree diagram coming up describing this. So here we go. Okay, here it is. Dialysis, 52% survive, 42%, 48% die. Okay, so the transplants, you got 96% success, and of those 96% success, 82% keep going on to living. 8% of those go back to dialysis, and then of the dialysis, you get a 70-30 who survive or die on that. And that's, those are the people that went through transplant, succeeded, 8%, and then 70% of those guys went on to survive, and 30% went on to die. Okay, here's that remaining 10%. They die. Okay, and then of these 96%, 3% had to go back to dialysis, and then those guys have the 52-48 success rate. And then of those people that got the transplant, that 1% died right there. Okay, does that make sense? That's all given in that word problem right there. All right, and that's it.